let's see. Everything go. Yeah. So it puts the tool up a certain way. That's why you see it. So it indexes. So that's blowing any chips off of the tool.
Oh, okay.
That's what that's about. See, and this is, I thought I had the coolant on in one of these. See, and it started way out here this time.
Oh, okay.
And that's what it should have done.
Oh, wow.
Well, I'm still out of the way, you know.
But I didn't see those go way out.
What?
The tool, the blades.
It's just one, actually.
It's just one?
Yeah, it's one bar with a tool. See, this is...
I see. It's going so fast, you can't tell.
I'll turn that back on another tool. That's why I said a minute ago I edited the tool, and I thought it would have... There's two places to edit it, and one would just make it every time I chose that tool, it knows not to use a coolant, it knows, you know, its dimensions and all that. And then there's the tool used for this job, and that's where I screwed up probably. See, and I went too far there.
Oh, I see.
You know, so I'm going past the bounds. I mean, it's not hurting anything, it's just weight. You know, a professional would go, what the hell are you doing over there? That's money right there, we ain't got time for that shit. But, you know, I want to prove something first, and then after I get it to successfully do those things, then we'll worry about refining the speeds.
How do you clean it up?
What do you mean?
You just squirt it out and drain it out?
It's got a drain. So it's being circulated. There's two drains, one on each side. There's a tank down there, and so all the chips will get washed out.
Oh, they will?
Yeah, and there's a tray down there with holes in it. So, yeah, it's pretty well designed. I mean, what I'll probably end up doing is also hooking a little hose up that has this same coolant where I can just kind of wash it down with that. In fact, you know, the people in the big machines have, wash down hose so they can do that. See, like that was a waste of time, but so I was having multiple problems and I was trying to deal with it, and I obviously wasn't loading the correct code.
But it's working now.
Yeah, and I think we should probably have no problem with this going on. Well, we should have less problem than I've been having, let's just put it that way. But yeah, this is what it should have done first. I should have seen it deck the whole part and get us a fresh start at the same level. And you know, when you'll feel this when this part's through, well, let's just see. I'm talking a lot of shit now. You know, it could all go wrong. It ain't too late. I'm sure that'll sound great.
Okay.
So it's going to turn that off. It's going to change to the drill bit again. It's going to drill 3 holes this time in rapid succession at 14 inches a minute, 4,000 RPMs. Preferably. Hopefully that's what it's going to do. We're going to find out right here. Got your fingers crossed? I do. I should have my... So we already know it drilled this hole. Now it's going to drill a fresh hole. Did it drill that first hole all the way through? Oh shit, we're gonna find out.
Did it drill 3 holes already?
Yeah. Now this will be the exciting part. Not really, but. So it's gonna bore that hole out. Actually, it should bore all 3 of them. Is it going the right depth? Says so. See, I just don't want to just shove that next tool down in there. You know, that little bitty frail thread mill. Get everything in right. It's not gonna. That'll be a junk $40 tool. It's almost like gambling. So it's going to do those processes again with a little finer cut. So theoretically, it would have cleaned this hole up where it looks real pretty. It would be a light cut, and typically you'd probably do it with a different tool that you had a nice edge on. You'd use one that was for cutting the big hole, and then one for, that's if you're doing real high quality stuff. So then here in a minute, that chamfer tool is going to come out again, and it's going to go around it. Now, that first hole I'd already screwed it up a few times, and it chamfered it. So, but this will probably look a lot better than that. See how nasty the holes are at the top, and then here this next tool will cut around, and it'll cut a little bit of a relief, hopefully, around all of them. See, and this one's not going to cut anything because there's really not anything to cut. This is the moment of truth. And I can tell you, I'm puckering. I've never used this tool before, and I've watched it millions of times on different videos, and it's a cool as hell process if it works.
Okay. The threader.
Yes. It's called a thread mill. 10 passes. I've got it doing a pretty light cut. So it's just touching now. You just heard it.
And this has to move exactly right.
Yes. This thing is called a servo-driven machine, and it's ridiculous how accurate that thing is. And the processor that's figuring out, the circular interpolation and helical. So it's coming up and going out and then moving out about 5 thousandths of an inch. I can't remember. I made it do 10 passes because I was conservative and scared. And you ain't gonna do that with your hands.
Nope.
And so what's cool about this is, say the thread was too tight, I could just adjust that a hair and rerun the same file, and it'll cut in exactly the same place and move it out. So you could adjust it, and then once you proved it, you would keep that file, and you would know, if your customer wants a certain, they're called qualities of thread, how tight that thread is. So you could adjust all that. And I can use that same tool to cut any 60-degree American thread. Okay. Instead of having taps. And it's a lot more accurate than a tap. It's a lot more expensive than a tap, too. And the scary thing is, I better not say it yet, we're not through. Shit, did I not put an M30 at the end of this game? Yeah, it's gotta be done. And the $25,000 question is, do I have a 3/8/16 bolt?
Oh yeah.
To see, I just wanted to do something, to see if I could get all these to work. Yeah, like in the big machines, these nozzles for the coolant are programmed with the tool. So it'll know the geometry of the tool, how far it does it, and it'll actually guide those too. So the coolant floods the tool. And some tools actually have, that's it. So, 2 questions. Why does my spindle not turn off?